In this video, we're going to review single component systems. The objective will be analyze single component structure systems and break down a static problem into basic steps. Recall what we learned. The 5-step approach. Think about the problem, try to understand the problem, describe the problem mathematically, solve the equilibrium equations, learn from the solution. The question we're going over today is the beam AD shown below. It's supported by a cable BEC that runs over a pulley at E. The beam carries a load of 5 kilonewtons at its end. The beam weight generates a force of 0.8 kilonewtons and it acts midway between the dimension points A and D. Assume the following coordinate system. Positive forces in X are to the right. Positive forces in Y are upwards and positive moments are counterclockwise. We're going to find the moment generated by the beam weight as measured from point A, and the moment by both ends of the cable on the beam as measured from point A, and we're going to find the tension T in cable BEC. Feel free to pause the video and solve it on your own. We're going to draw out the coordinate system as shown here. We're going to find the moment generated by the beam weight as measured from point A. The beam weight will be 0.8 kilonewtons as it states in the question, and it acts midway between the dimension points A and D. We can draw it here in the diagram, a downward force 0.8 kilonewtons. And the distance will be half of AD. First, we can find the distance between AD. It will be 2 plus 1.2 plus 1 equals to 4.2 meters. Then we can write AM stand for the moment about A and W stand for the weight. Since the weight is acting downward, creates a clockwise moment about point A, and this will be a negative moment. We can write it as negative 0.8 kilonewtons times the distance, 1/2 of AD, which will be 4.2 meters here. And this will equals to negative 168 kilonewton meters here. Next, we're going to find the moment generated by the cable. We will write the tension of the cable as T here, and since it's a pulley, both ends will be the same for T. To solve for it, we need to break CE into its vertical and horizontal component. Solve this triangle use trigonometry. The horizontal component will be cosine 50 degrees times T, and the vertical component will be sine 50 degrees times T. We can now write the moment about point A as AM and T because this is moment generated by tension, and this will equals to the left part acting upwards create a counterclockwise moment, which we will write it as positive times the force T here times the distance 2 meters. And for the right part, the horizontal component is passing through point A, therefore no moment will be created. And for the vertical component, it also acts upward, providing a counterclockwise moment, which we will also write positive here, and times the force sine 50 degrees times T times the distance 2.0 plus 1.2 meters. This will equal to 2T plus 3.2 sine 50 degrees times T. Lastly, we're going to find the tension T in cable BEC. Firstly, we're going to write down the equation of equilibrium here, and we can bring back what we get from the previous two questions and put them into the equation of equilibrium. The moment generated by beam weight will be negative 1.68 kilonewton meters, and the moment generated by the cable 2t plus 3.2 sine 50 degrees times t. In addition to that, there is a 5 kilonewton force created a clockwise moment about point A, which will be a negative 5 kilonewtons, times the distance 4.2, which will be the distance between A and D, 2 plus 1.2 plus 1. And so for T, we will get T equals to 5.1 kilonewtons. And in summary, here are the answers for those problems. That's it for the video.